Okay, here is some practice with half-life and isotopes. So, half-life refers to when you have a radioactive substance, or basically anything that is decaying. The half-life is a measure of how long it takes for half of what is left to decay. And isotopes refer to an atom that is the same element, meaning it has the same number of protons, but has a different number of neutrons. We also have some stuff dealing with ions in here. Ions are the same element, just with a different number of electrons. So, looking at you should definitely have a periodic table and a calculator for this, so get that now. Put this on pause. Make sure you have your periodic table and calculator, and then proceed. Alright, looking at your periodic table, nitrogen is element number 7, meaning it has 7 protons, and if you look at the atomic mass, it says 14.007. So, the number of, let's zoom in here, so we're on nitrogen, number of protons will be 7. Okay, and then for the number of neutrons, so I'm doing the protons and neutrons first. Number of neutrons, we have the atomic mass is 14 minus the number of protons equals the number of neutrons. So I'm going to abbreviate atomic mass minus protons equals neutrons. That always works, and for some of these is how you will actually calculate number of neutrons. Okay. Number of electrons is going to be the same as a number of protons unless it is an ion. Okay, the charge will be balanced out. These are negatively charged, these are positively charged, so our number of electrons is just 7. We know that because we're dealing with nitrogen, not an ion. Now, number of valence electrons, you have to look at the periodic table, and nitrogen is in row 2, so we're counting from the left. And from the left, we have lithium, and then beryllium, and then boron, and then carbon, and then nitrogen. So we went 5 in from the left. 1, 2, 3, 4, 5. Nitrogen will have 5 valence electrons. Valence electrons are the number of electrons that the atom has in its outer shell. So notice how there's two left over. It has 7 electrons, so there's 5 valence electrons. Those 2 are in the inner shell, and if you look at your periodic table, up at the hydrogen and helium, that's where those first 2 are in the inner shell. Okay, moving on. C13. So let's take a look at carbon. And carbon says this. 6, and we have a 12.011. Okay, so this means that a normal carbon atom has 6 protons, and with an atomic mass of 12, it will have 6 protons and 6 neutrons. Yet, this C13 indicates that 13 is its atomic mass. So we could actually even write it like this. Carbon, that's a little 13 down there. Okay, so carbon will always have 6 protons. If it has a different number of protons, it will be a different element. The 13 would be down here, indicating that's its atomic mass, and so 13 minus 6 would give 7 for the number of neutrons. Okay. Atomic mass minus protons equals neutrons, just as we did up here. Atomic mass minus protons equals neutrons. So for C13, we have 6 protons, 7 neutrons, and because it is not an ion, the number of electrons will be same as the number of protons. So that is 6. And valence electrons, we're looking at carbon, and as we move in on the periodic table, it goes lithium, beryllium, boron, carbon, totaling 4. Okay, so this is an isotope. not an ion. It is an isotope because it has a different number of neutrons than it normally would. Normally carbon would have 6 protons and 6 neutrons. This is heavier. It has 7 neutrons. It is an isotope. All right. Helium, looking at the periodic table, we have, and I think this one is just straightforward. Helium has 2 protons and 2 neutrons. Notice how the atomic mass says 4.0026, looking at your periodic table. So 4 minus 2 is 2 neutrons. It's going to have 2 electrons to balance the number of protons. And notice how both those electrons are in its only shell. They are therefore valence electrons. Okay, the outer shell is simply the first shell. That's all it has. So it has 2. It has a complete shell. It is happy. Notice how it is in the noble gases, that column to the very right of the periodic table. Next up, sodium, Na. So we have Na 11 and 22.99. And a 22.99, I'm going to round to 23 just for ease of calculation. So valence electrons. Take a look at sodium. As we count in from the left, sodium is the first element. It has 1 valence electron in its outer shell. Its total number of electrons will balance its protons, okay, which is 11. So it will have 11 electrons and 11 protons. And then for the neutrons, we have an atomic mass of 23, 11 protons. Atomic mass minus protons equals neutrons. 23 minus 11 equals 12 neutrons. Okay. Now this is indicating an ion, Na plus and Na minus. Alright. So our normal sodium has 11 electrons, okay, and 11 protons, so the charge is balanced. We're going to say charge is 0. But when we have this situation, this is indicating that the charge is plus 1, okay. So if the charge is plus 1, that means that it is missing an electron. Electrons are negatively charged. So if it loses an electron, its charge will become positive. If it gained an electron, its charge would become negative. So everything is going to be similar to the sodium above, except that because its charge is positive, it has 1 less electron. It has lost an electron. So we have 10 electrons. The number of protons and neutrons will be the same. But looking at the periodic table, if that sodium atom lost an electron, it would bump it back to where neon is. And so the number of valence electrons would be 8. It would have a full shell. Look at the periodic table, look at sodium, Na, and look at where neon is, 10, okay. If sodium lost its 1 valence electron, it would then have a full shell, an 8 in its second full shell. Okay, and by the way, this is normally what happens to sodium atoms. Next up, Na minus. So this would be like the normal sodium atom, 11 protons, 12 neutrons, yet the number of electrons would be greater by 1. Okay, so instead of 11 electrons, it has 12 electrons, and instead of one, instead of one, where am I? We're going to have to just ignore this guy. Let's see, yeah. Instead of 1 valence electron, it would have 2. Okay, so if you're looking at the periodic table, We got sodium, you add an electron to it, it would be like magnesium. Okay, so that is the second column in, it would have 2 valence electrons. Sulfur in the periodic table is way in there, it's at number 16, okay, atomic number 16. So it has 16 protons. If we look at its atomic mass, that is 32.065. So we just round and we do 32 minus 16. Atomic mass minus protons equals neutrons. Okay, 16 neutrons. The electrons will balance with the protons because it is not an ion. Notice how there's no plus or minus written. And then for the valence electrons, we're counting in. It goes sodium, magnesium, aluminum, silicon, phosphorus, sulfur. That was a total of 6. Okay, 6 valence electrons. Count in from the left in that row to get the number of valence electrons. Iodine is like this. Iodine, 53 and 126.9. Let's see, my old eyes. 126.9. We're going to round to 127. Okay, 127. So to find the number of neutrons, we're going to do 127 minus 53. Calculator doesn't work. That's cool. So 127 minus 53 will give us a 4 and a 12 and a 74. Okay. So we're going to have 53 protons, 74 neutrons. Iodine. 50, what was that? 53 and 74, okay. 53, 74, 53 protons, 74 neutrons. It is not an ion, so the number of electrons will balance the number of protons. And then for the valence electrons, we are looking at the number of valence electrons. We're counting in, and you can ignore the transition elements. So it goes rubidium, strontium. This is in the 1, 2, 3, 4, 5. Okay, 5th row. Rubidium, strontium, indium, tin, antimony, tellurium, and iodine. So it's going to have 7. Okay. 7 valence electrons. It is a halogen gas, and those are reactive. They want an extra electron. So with one more, it would have 8 and be a happy atom with a complete shell of valence electrons. Okay, lastly, neon, atomic number 10, 20.18. So it looks like 10 protons and an atomic mass, closest when we round, is 20. So 20 minus 10 gives us 10 neutrons. The number of protons would balance the number of electrons, and in terms of its valence electrons, it is a noble gas. It has a complete shell, or 8. Okay. Next up, half-life. So if the half-life is 5 hours and we're drinking a glass of orange juice with some amount of vitamin C, what it means is that in 5 hours, half of it will disappear. So for the 80, we can go like this. We start with 80, okay, and this is at 0 hours. After 5 hours, divide by 2. 80 divided by 2 is 40. After another 5 hours, 40 divided by 2 is 20. After another 5 hours, 20 divided by 2 is 10. After another 5 hours, 10 divided by 2 is 5. After another 5 hours, 5 divided by 2 is 2.5. So the confusing thing, these are hours, and this is amount. The confusing thing is that people tend to think, well, if 40 disappeared here, another 40 will disappear here, and it'll all be gone. That's not the way it works, though, okay? In these 5 hours, half of this amount decays or disappears. So, after 5 hours, how much do we have? We have 40. After 15 hours, we calculated we have 10. And then after 20 hours, we calculated we have 5. And these would all have units of milligrams. Milligrams, milligrams. Okay. We're going to do the same for if we had 100 milligrams. So I'm going to pause and grab my calculator. I want you to see if you can actually calculate those. Okay, so let's see, we start with 100. So the 100 would go to 50, and that would decay to 25 after 10 hours. So this is 25. Then it would go to 12.5, and then it would go to 6.25. 6.25, and then after another 5 hours, we're going to divide that by 2, and we get 3.125, and this is again in milligrams, milligrams, milligrams. So notice how you don't just divide by 2 and write the answer here. Okay, it depends on this. This was 10 hours, meaning we went one half-life to 5, and then another half-life to 10. So that was divided by 2, that was divided by 2. Similarly, from 10 to 15 to 20, we went 25 divided by 2 and then divided by 2 to get the 6.25. Okay, hope that helped. You have a second page to this, so flip it over and solve them yourself. I think it's a class we'll go over the answers or something like that.